My name is Stas and I'm going to continue with my Stable Diffusion toolkit for Houdini called Stable Houdini. If you missed it, Stable Houdini is a set of assets that allow Houdini to generate images using automatic 1111 and process them in Houdini. Link to assets and to the last lesson, of course, in the description. Today I want to show you how to create dozens of variations of your design in a matter of minutes. Let's get started. First, we'll start automatic 1111 and Houdini. Now install the assets. Go to Assets/Install Asset Library menu. I assume you already downloaded them from GitHub. In this folder, we also have a Python folder. If you transfer the assets to another directory, then transfer the Python folder as well. Let's select all the files that we have in the DAW folder. Click Install. Let's start with our scene. I will add a geometry node, go inside and here I will make a couple of inscriptions using the font node. The first inscription I will have is stable. The second inscription is Houdini. I remind you that by dragging a node while holding Alt we can create a copy of it. So, we have two nodes, we select both and pull the pin down while holding Alt and get the merge node. Now we need a transform node. Let's move this higher and choose a nice font. Now let's append a poly-extrude node and extrude these letters. We want to get cool letters like this. And in addition, let's go here and click the Output Back checkbox so that these polygons are also created for us. Click on the camera icon while holding Ctrl and get it in the same place where we looked in the viewport from. Let's set up the camera. Reset everything, remove unnecessary rotation. Let's make it more wide angle and slightly zoom into our inscription and raise it a bit. Camera resolution is very important. It will determine the resolution of our image. Since we're working in Stable Diffusion, the resolution of each side must be divisible by 8. And we must understand that when working with Stable Diffusion, we cannot work with high-res images. Well, we can, but nothing good will come of it, as most of the models are trained on low-resolution images. Therefore, let's set the resolution here to about half of Full HD, 960 by 544. And then we should generate a depth map from our image. And for this we installed our assets. I have an asset called depth map. There is a camera in the parameters which is cam1 by default. Here we load our object instead of character. Let's turn off the object and turn off the lighting. We will see that we have a depth map. But as you can see, even if we change power, everything changes too drastically. The thing is that the depth map node colorizes points. And there are very few points as such on this mesh. That is, there are points at the ends and no intermediate points. We can fix it in several ways. For now let's just put some number into the divisions parameter on the poly-extrude node, let's say 50. Let's exit the geometry node and make sure that it has already become a little better. We can play with power and make such a cool sharp depth map. Because of the high power value, bands appear. Maybe we don't need it, so here we can go to the poly-extrude node and increase the number of divisions even more. Well, in principle, that's all. Now we can work with Stable Diffusion. Let's create a top network and immediately set up the local scheduler. Set custom slot count to 1 and job params to single. This is necessary so that all our tasks are processed one after another, because if we have several tasks generated at the same time, automatic 1111 will not be happy about it. First, we will add an SD switch model node. After we put a first node from the SD toolset for the first time, a few things happen. First, we have appended a common Python path for this project within DAW folder. Secondly, if there was no config folder on the disk yet, then this folder is created. Look, the config folder has appeared in the DAW folder, which contains the config.ini file. If we open it with Notepad, we will see the basic settings. You can change the default URL of your automatic 1111. For example, if you're working with a remote server or with a different port, then you can set it here so that you have the correct server set up immediately when you start the project. Secondly, here you can enable authorization. Instead of false, you can type true or yes, and add username and password here. This will enable the basic HTTP authorization. You can install automatic 1111 somewhere on your render farm and work with it using your local computer. After you have changed the config, you will need to restart Houdini for the changes to take effect. So, we have added the switch model node. This node allows you to switch the model that is currently set to automatic 1111. We can work without it because there is already a model in the automatic 1111 when we launched it. But I recommend, since we're working in such a professional environment, put the switch model node anyway, because you can switch the model in automatic 1111 and forget about it, load the project next time, and you will have different results. And the results should be the same every time you load the project. We are professionals, so let's use the SD switch model node. Here we can choose a suitable model. I recommend using the Dream Shaper model. I think it's very cool for design needs. It allows you to work at a higher resolution than other models, and it gives pretty nice pictures. Go to savitaI.com, type Dream Shaper here, while you're looking at endless anime girls. Click on Dream Shaper, select Download. Then copy the downloaded file to your automatic 1111 installation folder /models/stable diffusion. And after that, this model will appear in your automatic 1111, so you can choose it. We have switched models. Now let's generate a depth map. To do this, put Rop Fetch node and select obj/depth map in the ROP path, go inside RopNet and select OpenGL. It is important to choose the OpenGL node, because in this case the Rop Fetch node will recognize that there is an image in OpenGL and assign it as an output file for the following nodes to use. Here we make sure to select Cook Type, in Process, and we can also go to Frames and Batching and select Rop node configuration so that nothing changes on the Rop node. Now, generate this node. I remind you that you can generate using Cook, or using Dirty and Cook this node. The model has switched and on the disk, in the render/temp folder we will have a depth map. Let's move on to generating our super pictures. To do this, we need an SD prompt node so that we can experiment with our prompts. Next, we need an SD Dream node, it's our main node. And we need an image preview node to view our images. The image could be viewed in composite view. You can even close the scene window. Let's get started, and the first prompt will be like this. Flying crystal letters, let's say it will be glass, reflective surface, highly detailed, hyperrealistic, and you can add vivid colors. This will be our first prompt. As a reminder, the SD prompt node writes the prompt to an attribute called prompт. Let's cook it and middle-click on the circle. We can see that our prompt is here, in an attribute called prompт. If we change something in our prompt, for example, remove some words, and just press cook, then nothing will change. As you can see, everything will remain the same. The fact is that top nodes have the so-called dirty flag. Dirty means that it has been changed and needs to be recalculated. If this flag is not checked on the node, then it simply will not be recalculated. Therefore, if you want your changes to take effect on the node, then you need to select dirty and cook this node. After that, the prompt changed. Don't make this mistake. Let's restore it as it was. Select dirty and cook this node again, or the Shift+V hotkey, which I will use a lot. We have our prompt. Let's go to the Stable Diffusion Dream node. First, let's select Upstream Image Resolution, so we use the resolution of the incoming image, which is our depth map. Secondly, we select the prompt source, Upstream attribute, so we use the prompt that we created on the SD prompt node. We can make sure we have the correct attributes here. We can add a negative prompt as well, to negprompt attribute. Let's leave it like that for now. The rest of the settings can be set to default. But the most important thing awaits us in the ControlNet folder. With ControlNet we can use the depth map to generate our image. Let's add a ControlNet using the plus icon. Select upstream image and we will send it to the model, which is called control version 1.1 depth. Let's make sure that we have the append name checkbox here so that the number of the current batch and the number of the current task are added to the file name. Let's choose a path to write to like $OS/$OS and name this node letters. That's it, we can start generating pictures. I'll use a few batches. When we work with stable diffusion, a lot depends on the amount of your video memory. For example, the number of batches that you can calculate at the same time. When I set the batch number here to something other than 1, it means that this number of images will be rendered on my video card at the same time. With my video memory with a resolution of 512 by 512, I can generate about 30 pictures at the same time. But our images are of a higher resolution, so maybe I can generate 10 batches. If you have less memory, you can see errors in the command line console, and that errors will say something like CUDA error memory blah blah. If you see such an error, then you do not have enough video memory. You will need to reduce the number of batches, you will need to reduce the image resolution. This is what you will run into all the time. You just need to test how many batches your video card can withstand, what resolution you can work with, and so on. Let me use 4 batches, and on the image preview node I will click Cook. Everything is done and my pictures appeared in the composite view. I preview the image from the currently selected task. Switching between tasks, I can immediately see these images. I remind you that this can also be assigned to hotkeys. I talked about this in the first lesson. I have it assigned to 6 and 7. I can quickly switch, and when I like some picture, I can click Save. Let's not do that for now. Then we can work with this prompt, we can somehow ennoble it, add new inscriptions. Let's add motion design. It usually adds, guess what? It adds lens flares. You see, some light leaks has already appeared here, some flares, some aberrations. But what if, for example, you don't have enough video memory even for 4 batches, but you want to see several pictures at once? Everything is very simple, we can increase the number of tasks. That is, batches are those pictures that are generated simultaneously, in parallel on the video card. But we can also put a node called generic generator and choose that we want to generate, for example 4 tasks. Let's immediately check sequential, copy inputs to outputs, so that the input files also appear on the output. And you can choose flatten work item indices. When we calculate this node, we will have 4 tasks. Both the prompt and the picture were preserved. Thus, now we have 4 tasks at the input, and here we have 4 batches. The output will be 16 images. If you don't have enough video memory, you can just use generic generator instead of a batch. The only difference is that batches are generated in parallel, while tasks will be generated one after the other, sequentially. It just takes more time. We have 16 tasks, let's spin them here. We have an interesting problem. If we click on the first task, we see such a picture. If we click on the 5th task, we will see the same picture. Why is this happening? Because there is a fixed seed on the SD Dream node. For all incoming tasks, it will be the same, 0. At the same time, when we work with batches, automatic 1111 will automatically increase the seed for each next batch. Seed for the first task and for the second task will be exactly the same, the pictures will not change. What we can do, we can put -1 here. This means that each time the seed will be chosen randomly. This is also an option, but we want everything in the project to be deterministic, so that when we open the project in a month, we can get the same results. Let's just put an expression, we can write some initial number instead of 0 and plus at pdg_index. And in the last update of the asset, I added a checkbox called sequential seed that does the same for you. Now you can just check this box and put in some initial seed. For each subsequent task, you will have a new unique seed. Let me turn off the generic generator for now, we don't need it in this case. I still want to work with regular batches. Let's say we liked the first generation. We want to go further and experiment with prompts. Here we can fully appreciate the power of Houdini. Since we are working with nodes, that is, One node is one prompt. All you need to do is drag this node, holding Alt and copy it. Let's say here we have this prompt with crystals. And here we can start working on a new prompt. Old wooden letters, fantasy, overgrowth, dramatic lighting, highly detailed, hyperrealistic, vivid colors. Dramatic lighting means backlight, that is, there will be more lighting from behind the object. Let's cook it again, and now we have a completely different picture. Wooden letters. As you can see, the dramatic lighting is present, the shadows look cool. I even think that we will leave this prompt as is. Let's drag it with Alt, and we will have another one, sci-fi, flying futuristic blocks, panels, metallic surface, dramatic lighting, highly detailed, hyperrealistic. Let's see what we can get out of this. I don't really like it. Let's first change it to flying futuristic letters, colors can even be removed, neon lights, cyberpunk. In general, you are already starting to be creative with your prompts. Here we already have some neon things. Why not? Basically it looks nice. Thus, you can collect a bunch of different options for prompts. Let me show you another cool trick. We have a stable diffusion node called Png Info. Let's say you already have a generated image that you like. You can of course just copy the prompt from it, or you can take an image, put it to this node, and at the output of this node you will have all the parameters of this generation because Automatic 1111 saves all the parameters to PNG files, including prompt, negative prompt, CFG scale, steps, model etc. Let's select a file here, let's say it will be this previously generated image. And I want to copy parameters from it. I just go to the Png Info node, paste the path to this image and cook the node. If I press the middle mouse button, we will see that I have all the image parameters here. Here I have CFG scale, denoising strength, model used, negative prompt, +1, seed, steps and so on. If I want to completely clone the image, I can use all the parameters from it. To do this, I need to read these attributes. The only thing is that we store these attributes as strings. That is, if you need to read this line in some numeric field, then you need to add the atf function. Let me show you how to do it. For example, we can write atf at cfg_scale, that is, the name of this attribute. Let's see, here is cfg_scale. When we cook the task, we will substitute the 7 that comes here as an input. Let's choose delete channels as now we don't need it. The main thing is that we have a prompt and a negative prompt here in the correct attributes, that is, we can directly connect this node here, to the letters node, and immediately cook it. Some kind of desert formed here, it all came from the prompt. You can add another SD prompt node here and add stone letters. When we cook this node, we will have this inscription stone letters added to the end of the prompt, separated by comma. This way we can grow our prompts and get something new. Well, let's probably do one more prompt. Let's remove all this, remove motion design, and put painted letters, color splatters, splotches, ink drips, highly detailed, hyperrealistic, vivid colors. And we will generate 4 more pictures. We got such funny letters. Now we can just select all these nodes, pull the pin down, type merge and all our prompts will go to the merge node. And when we press Shift+V we will see that we have created a task for each node and on each task we will have the prompt. And now we can stick it all here, generate it, and we will have all the prompts that we came up with in one sequence. Thus, we can come up with a dozen of these prompts, multiply them by batches, multiply them by tasks using the generic generator node and create 100 of pictures and send them to your art director. Let them admire your art. Everything has been generated, and we can look at all our images in a row in one sequence. And on the disk they were preserved in one sequence. You can immediately load them into any player or load them into any nonlinear editor. Let's load them to DJV view. Select 8 frames per second and admire the images. In just a few minutes, we assembled such a cool thing. What else can be done about it? We're using a control net called depth, and because of that, our pictures seem to lose some detail around the letters. Letters are always present here, but at the same time, some surrounding details may be lost. We can add details by adding another control net. In my automatic 111 settings I set up that I can use 3 control nets at a time. I'm adding a second control net here. I can use another image of my own and use it as an input. I'll take the file pattern node and load the same image. I'll just put the name of this file into the file pattern node, select Shift+V, this image has loaded. We have a node called SD Preprocessor. It allows us to use preprocessing, that is, we can process our images to get depth maps, normal maps, and everything else that can be used in ControlNet. Since here we rendered the depth map ourselves, we do not use the preprocessor, but directly use the ControlNet model. Here we can also add a preprocessor that converts our incoming image into some kind of map. Let's also put an image preview node here and select a depth preprocessor. When we cook our node here, we will see that our picture with labyrinths has been transformed into a depth map. We can see what preprocessors exist. We can try them one by one. Some of them will not work. For example, Clip Vision is a preprocessor that does not produce an image, it kind of gives a description of this image. But the majority gives out image processing. Maybe you want to use normal map. You can select normal preprocessor and get a normal map and use it somewhere for relighting. You can select an entire sequence on the file pattern node using an asterisk and process the whole video this way. Get a depth map to use it somewhere in the compositing software. In general, it's a pretty cool thing. For example, I can use the simplest preprocessor, Canny. It looks like this, gives such a line art. Feel free to experiment with these threshold A and B settings. Let's stick with Canny. I'll copy this image path again, and in the second control net I'll choose File instead of Upstream Image. I'll paste our picture here and select the Canny preprocessor and select ControlNet 1.1 Canny as the model. Let's now select one branch, generate it and see how Canny changes the picture. We use both the depth map and these lines that come from a completely different image. Now we see how different control nets compete with each other. Now we can adjust the degree of their participation in the picture. Each control net has these parameters, weight and guidance start and end. The generation takes a certain number of steps, in this case, as far as I remember, it is 20 steps. So guidance start and end shows at what point in the generation the control net calculation starts and ends. For example, we can generate half of the generation only with the depth map, and only from the second half of the generation Canny will turn on. Or we can reduce weight, the power of influence of this control net. Let's start with weight and experiment. Like many things in neural networks, everything here depends on your experiments. The more often you try to do something by changing the parameters, the more you will understand and feel how the neural network works, how your favorite model specifically works. I reduced the weight, and now this is what happens. It looks better, we have a background now. It slightly affects the letters themselves, so let's additionally reduce the guidance end. Let's say the last 30% will only have a depth map. Well, here we get such a cool thing. And we chose prompt cyberpunk and sci-fi. Now we can turn merge back on and see how it looks on all of our prompts. In terms of design, your work is reduced to the point where you need to make some basic shape of your scene, render a depth map from it and use it for generation, adding all sorts of cool stuff. Then, of course, you can refine this picture, throw chromatic aberrations on top, as you like. Ultimately, this simplifies the brainstorming process. Look, cool desert motifs have appeared. This is great. I like it. Here's such an arch turned out from trees, not bad. This looks a bit strange, but note that we have this thing now turned into crystals. The surrounding frame has become so crystalline, low poly. And as you can see, pretty cool results are obtained, although we spent a minimum of time. Let me now show you how to make a high resolution out of this. We run into video memory. The Dream node has a tab called Hires Fix. It only works in text-to-image mode. After generation, it upscales the image using this neural network upscaler. In this case, it doubles the resolution and then runs it through image to image with this denoising. In this case 30% of new details will be added. That is, our 960 by 544 pixel image will be upscaled to 1920 by 1088, run through image to image and no details will be lost. The problem is that it may not fit your video memory. This is especially strongly related to the number of batches. I know that my video memory fits 2 such images. I can put 2 batches here, and at the same time add the generic generator in addition and generate 2 tasks. I will have the same number of images, but they will be rendered in full HD. Well, since we work at Houdini, let's do it in a smart way. We will make a separate branch for high resolution. Here we will revert everything back. And in this branch, we will even call it high res, we leave the hires fix. Afterwards we can add a switch node and put one here. We can bind the parameters of these nodes to each other so that nothing gets lost. Also we can do this, go to Actions and create reference copy to create a copy of this node completely dependent on this node. We will do so. I'll cut off all the excess wires. On this node, we need to change the batch number, right-click and delete channels. Put 2 batches here. Or let's say you can have 1 batch and just increase the number of tasks. Let's also remove the file name, right-click, delete channel. We must put the same $OS expression here. In seed, let's also put the same expression. And of course we need to add hires fix in the same way. Delete channels, enable this checkbox. And here let's select delete channels on all of these options so we can change them. Click on Cook, after that we will generate high-resolution images. Here's the tutorial. I hope you find it interesting and useful. All links in the description. If you have any questions, write in the comments. Be happy and work in Houdini.